Good morning, everyone. Thank you for joining this morning. It's great to see so many people have joined. My name's James Lydon. I'm the channel sales manager for Sunsynk in the UK. So my role is working closely with our partners in the channel, especially Segen. So I'll get started straight away. Okay, so a little bit about Sunsynk. So for people that aren't familiar with Sunsynk as a brand, the group, we've been established more than 30 years, so we're a well-established company. We've been trading in the UK for approximately 3.5 years. Our main market is still South Africa. We have a leading market share in South Africa, and we decided to bring our product to the UK about 3.5 years ago, and it's been received really well. We are world leaders in inverters and battery storage. So we give ourselves the tick on the world leaders part. And, as a business, we're constantly innovating. Our CEO, Keith Goff, back in the day, he himself, and it was a professor from a university, they invented the technology behind a bidirectional inverter, which as we now know as a hybrid inverter. So that gives us that tick on, world leaders on innovation. We have trademarks in every country where trademarks mean anything. We've got offices in South Africa, the UK, Hong Kong, Australia, Spain, the USA. We've got an office in Dubai and also in the Netherlands. So we have quite a large footprint. In the UK, we have a 30,000 square foot facility where we hold all of our stock. So if there's anything that Segen don't have in stock, they can get from us on a next day basis. So, stock availability is key for us as a business. Over 815 gig of power installed globally as a group, internationally recognized brand. And probably one of the most important things as a business for you guys as installers is we have in-country and in-house tech support in each country. So in the UK, we have a full dedicated UK technical support team. And, as a manufacturer, we know how important tech support is to installers. So we want you to be able to pick up the phone, speak to our dedicated tech support team who can remotely access any system you've installed. We can check all the settings. We can talk you through any issues. So yeah, UK-based tech support. Okay, so our range, I'm going to cover it off in the next few slides. But some of the key features in our whole range, whether it's a 3.6 single phase hybrid inverter, all the way up to a 50 kilowatt high voltage hybrid inverter, the USPs that we've got listed here are the same across the full range. So the first one is quite basic, but in every box, we have the Wi-Fi logger included as standard. Some manufacturers will charge extra for that. So we have that in the box. We also manufacture a LAN logger, so that is purchased separately. But if you have a site where you require a hardwired connection, we do have those available. And we are also in the final stages of pushing our 4G logger. So we will shortly have a GSM logger. As a business, a lot of our kit will go into social housing and new build, or sites where they don't want third-party kit connected to their network. So yeah, we will have the 4G loggers and they will be available in the next couple of months. All of our hybrid inverters are IP65 protected, so they can all be installed outdoors, no issues whatsoever. They all have a built-in UPS output. So, as you guys know as installers, with a standard PV system, with a hybrid system and a battery, if that end user has a power cut, they will not be able to access the power from the PV or the batteries unless they have it wired in a certain way, whether it's a gateway. But with our inverters, we have that dedicated output built into our inverter. So anything physically connected to our inverter will remain powered if there is a power outage, which, it negates the need for a gateway, and it does work quite well. Rapid battery charging current. So this is, it's quite a big USP for Sunsynk. So with our hybrid inverters, we can charge the connected batteries at the rated value of the inverter. So if we have a 5 kilowatt hybrid inverter, we can charge the connected batteries at 5 kilowatt. Whereas there's quite a few others on the market where if someone's got a 5 kilowatt hybrid inverter, they might be limited to only charging them connected batteries at 2 kilowatt or 2.5 kilowatt. So yeah, with ours, it will go at full tilt at the rated value of the inverter. All of our hybrid inverters are compatible with PV and wind. So if the hybrid inverter's got 2 MPPTs, let's say, we can have one MPPT connected to solar and the other MPPT connected to a wind turbine. Wind turbines are a really complicated beast. So, we do have quite a few manufacturers who do use our kit with their wind turbines, but there's a lot that goes on with wind turbines before it gets to our inverter. For example, wind turbines produce 3-phase AC, so it's really noisy 3-phase AC that can't be used. So that 3-phase AC will need to go through a separate rectifier, and that rectifier is doing the opposite of an inverter, and that's rectifying it into DC, and that DC then comes into us. But one of the USPs for us is built into the inverter, we have what's called a 12-point power curve. If you imagine a wind turbine, the PMG, the permanent magnet generator built into it, it works similar to a bicycle gear system. So at 12 different points in our inverter, we can program if the wind turbine is producing this much voltage, the inverter will request this much current at 12 different preset points. So it's like, the inverter is essentially changing the gear on the wind turbine because as we apply more of a load, the resistance changes on the wind turbine, in turn generating more power. So that was a bit of a long-winded explanation, but our kit does work with wind turbines. All of our hybrid inverters will work completely on or off grid, so we don't need a grid connection. So if you've got a garden office or a remote outbuilding and you want power to it and you don't want to dig a trench from the main supply, with our hybrid inverter, our batteries and PV, it will work completely off grid. And if someone is completely off grid, unless it is maybe a garden bar or something where, if the batteries run out, it's not the end of the world. If it is a site where they need backup power, redundancy power, all of our hybrids have a dedicated backup generator input. So the backup generator would connect straight into our hybrid inverter, and our inverter can control if the generator supports it, which most do, some of the bigger ones. Our inverter can control turning that generator on automatically and charging the batteries and powering the load. So when the backup generator is connected to us, the power comes into our inverter and it essentially splits 2 ways. It will go one way to charge the batteries and the other way to power the load at the same time. So previously, if someone's been completely off grid, they would rely on a backup generator all the time they want power. But with us, that generator might only need to be on for a couple of hours because, as I said, while it's on, it's charging the batteries and powering the load at the same time. We have an auxiliary output built into all of our units. So this is a great feature. And essentially what this does, it works similar to your eddies and your iBoosts. So we've got that dedicated output on the inverter where we can set parameters, or the installer can set parameters for the end user to say, if the systems start exporting to the grid, we can divert that power to a connected immersion heater or, some air source heat pumps and any AC source, essentially. Ours works a little bit different to eddies and iBoosts, where they will start diverting at 250 watts or 300 watts. The way we program our system is we tell the inverter how much power the source wants. So if it's a 3 kilowatt immersion, we will say this source wants 3 kilowatt. And if the PV is only exporting, let's say 1.5 kilowatt, the inverter will send the 1.5 kilowatt to the immersion, but the other 1.5 kilowatt we will take from the batteries. So we're giving the immersion the full amount of power that it wants. Even though it'll take little bits of power, it's happiest when it's receiving the full amount of power. And that, those parameters are turned on and off dependent on the battery SOC. So the installer might say, okay, when the batteries get to 100% SOC, we'll turn on the diverter, but we will turn the diverter off when the batteries get to 90%. And like I say, yeah, it's giving it that full amount of power required. All of our units can be AC coupled. So if you've got someone with an existing grid-tied system, they can install our hybrid inverter. We don't need DC connected to it from the PV. So we can, you can have it as a purely AC coupled system. So you'd have our inverter, our batteries, and then down to the CT placement for our inverter, we can monitor when that existing grid-tied system is exporting, and we can divert that to our batteries. We see this a lot, more and more on big commercial sites where, the commercial site might be all on a grid, a grid-tied system with big commercial string inverters. But if they have an element of export, and at the moment it's going back to the grid and they're not getting paid that much for it, they can install our kit, whether it's, a couple of our 50 kilowatt high voltage inverters with our HV batteries, and we can divert any excess power to our batteries before it goes to the grid. Okay, off-peak charging compatible, so very standard. So we're fully compatible with Octopus, so we've got the full Octopus API, so we can control the battery charge and discharge rates dependent on the tariff. We're compatible with the Agile and the Flux. If someone's on a standard off-peak tariff, where it's, let's say, midnight till 6 in the morning, that can be programmed on the inverter, and that will take effect every day. But yeah, we are fully compatible with the Agile tariffs also, where the user can program, okay, if Octopus rates drop below this amount, the inverter can force charge the batteries from the grid. And we can also flip it the other way as well. So the user can set the rates that if it's a non-sunny, non-windy day and Octopus are paying more for export than they would normally, the user can program the system to dump the battery power back to them, and essentially get involved in a little bit of energy trading from home. G98, G99, and G100 V2 compliant on our inverters also. Okay, so our low voltage single phase hybrid inverters. So starting off, we have our 3.6 kilowatt, a 5 kilowatt, a 7 kilowatt, and an 8 kilowatt. So again, all single phase. On our 3.6, we've massively oversized the MPPT on it. So you can put up to 7 kilowatt of PV into our 3.6 kilowatt hybrid inverter. As it's a 3.6, obviously your max export to the property or the grid is 3.6, but it's keeping it within G98. So it's an easier process for the installer and the customer. And, let's say you've got 6 kilowatt of PV on the roof. The max you're going to export is 3.6, or send to the property is 3.6, but that other 2.4 we can send to the batteries. So yeah, it's keeping it within G98, but it's allowing us to sort of utilize as much roof space as possible. Our 5 kilowatt hybrid inverter has a 6.5 kilowatt MPPT. Our 7 kilowatt hybrid inverter has a 10 kilowatt MPPT. The 7 kilowatt's great as well because most DNOs are doing the G99 fast track, and that's on any systems up to 32 amps. So our 7 kilowatt hybrid inverter fits well within that gap. So yeah, on the 7 kilowatt, we've got a 10 kilowatt MPPT. With the 7, there's 2 MPPTs, and there's 2 strings into each MPPT, and it's the same with the 8. So there's 2 MPPTs and 2 strings into each MPPT. So 4 strings in total. And then the 3.6 and the 5, we have 2 MPPTs with 1 string into each. Okay, so still on our low voltage single phase hybrid inverters, we've got the 10 kilowatt, 12 kilowatt, and it's still the largest single phase hybrid inverter in the world, our 16 kilowatt max. So on our 10 kilowatt single phase hybrid inverter, we've got the double MPPT, so you can put up to 20 kilowatt of PV into it with 3 MPPTs with 2 strings in each MPPT. So it's giving you a total of 6 strings on the 10. The 12, again, 24 kilowatt MPPT with the same amount of strings, so 6 strings in total over 3 MPPTs, and the 16 kilowatt max, so 32 kilowatt input, again, over 6 strings. Our 16 kilowatt max is really popular for off-grid installs. If someone is off-grid, the max power they're ever going to get out the inverter is going to be the rated value of the inverter. So yeah, the 16 kilowatt ticks that box really well. Okay, on our 3-phase hybrid inverters now, We've got an 8, 10, and 12. So on the 8 kilowatt three-phase, similar to the single-phase ones, we've got 2 MPPTs. There's two strings into one MPPT and one into the second. And that's the same with the 10 and the 12. And we've got the PV input power there. So 10.4 kilowatt on the 8, 13 kilowatt on the 10, and 15.6 on the 12. Okay, so now our high voltage hybrid inverters. So when we say high voltage, they're still standard three-phase. The high voltage is on the battery side, which we'll come to in a minute. So on our high voltage, we do a 20 and a 25 starting off with. On the 20 kilowatt high voltage three-phase, we've got a 26 kilowatt MPPT. That's over 4 strings. And then the 25 kilowatt high voltage three-phase, that's got a 32.5 kilowatt MPPT. Again, 2 MPPTs with 2 strings into each. And then coming to some of the bigger units, so we have our 30 kilowatt and 50 kilowatt three-phase hybrid inverter. On our 30 kilowatt, we have an MPPT of 39 kilowatt, and on the 50, an MPPT of 65 on the max DC input. On the 30, we have 3 MPPTs with 2 strings in each, so 6 in total. And then on the 50, it's 4 with 2 into each, so 8 in total. Our 50s, they've been a bit of a game changer in the industry. There's been a massive gap in that commercial sector for larger, three-phase hybrid inverters. And our 50 kilowatt has been, it's been really well received. On the 50, we can parallel 10 50s together, so we can have 10 50s connected together, given a max PV input of 650 kilowatt, and each 50 kilowatt high voltage hybrid inverter can have 2 of our high voltage battery stacks connected, and each stack is 61.4 kWh. So there's max potential storage wise of over 1.2 meg. So it just gives you an idea on the scalability of all the systems. Okay, so this is just showing a couple of schematics showing different sort of scenarios with our kit. So even though all of our units are hybrid, we don't need batteries connected. So you might have an end user who wants to have the system installed, and they might want to monitor export for the first 3, 6, 12 months. So they can install our hybrid inverter and essentially have it working as a string inverter while they monitor all the data through the Sunsynk Connect app, and then add batteries onto it in the future. So with batteries, obviously this is most common with our hybrid inverters. This is just showing a standard sort of wiring diagram of a connected system with batteries. So this is with split load. So this is your essentials and non-essentials. So this is back to what we spoke about at the beginning with the USPs. So if there's a customer who is worried that they in an area where there's a lot of power outages, we've got that dedicated output built into the inverter for UPS. So it's a complete uninterruptible supply. So while it's on grid, that supply is always powered. So it'll work as a pass-through from the grid. And if there is a grid failure, it will work as a UPS. So, most installers, if it's a domestic property where there's not many power outages, but somebody wants access to power if there is going to be one in the future, you could essentially, install a double socket out of the inverter for the homeowner to then go, with an extension lead, let's say, and give them access to power. Or you can wire in a dedicated circuit. So that dedicated circuit, maybe the lights, Wi-Fi, the fridge, if there is a power cut, that will remain powered if there is an outage from the batteries and the PV. Obviously, there's different earthing arrangements required, but we do have that dedicated output built into the inverter. Off-grid. So as I mentioned earlier, all of our inverters will work completely off-grid. We don't need that grid supply. And this is just showing with the backup generator connected. So as I mentioned earlier, with the backup generator connected on a completely off-grid site, the installer can program on the inverter to say, if the batteries get down to 30% SOC, there's a contactor within the inverter that will close, that will send the signal to the generator to turn on. And then, yeah, as I mentioned, when that generator turns on, the power comes into the inverter and it will split two ways to both power the load and charge the batteries. Okay, AC coupled. So this is, as I mentioned earlier, working with a grid-tied system. So with the CT placement on our kit, we can monitor what the grid-tied string inverter is doing and what it's exporting to the grid. And we can program, as soon as that string inverter starts exporting, we can divert that power to our connected batteries. Okay, with a wind turbine, so yeah, again, as mentioned earlier, if the inverter's got 2 inputs on it or 4 inputs, we can split those inputs and have a connected wind turbine. If there's 2 MPPTs, we can have both for solar, both for wind, 1 for solar, 1 for wind. Okay, our low voltage batteries. So these will work with all of our low voltage hybrid inverters. So the only inverters these won't with is our high voltage model. So the 20, the 25, the 30, and the 50. But all of the rest of the range, these are fully compatible. So starting off with our L series battery. So it's fully IP65 and it comes in a 5.32 kilowatt hour module. And these are wall mounted or rack mounted as standard. So they come with the wall mounted brackets in the box, but they also have the 19-inch rack ears on if you do want to put them in a rack. All of our batteries are LiFePO4, so really safe battery chemistry. And they all have a 90% depth of discharge. And we can have up to 32 batteries connected in parallel. So it gives you an idea of the scalability of the system. And with our low voltage hybrid inverters, we can parallel up to 16 of our low voltage hybrid inverters together, with a total of 32 batteries connected to that paralleled system, essentially. So yeah, really scalable. And then all of our batteries have full advanced BMS software built in. And what that's doing is constantly monitoring the individual cell voltages. It's protecting the batteries if there's a setting that's been programmed in the inverter which the batteries aren't happy with. So yeah, it's constantly monitoring everything: temperature, battery voltage, individual cell voltage, and that's essentially looking after the battery. Okay, our new W series batteries. I know these are due to land with Segen shortly. There's been a lot of noise recently in the industry, especially around the PAS 63100 guidance in the market with where to store batteries. So, batteries are like electric vehicle, they work the same as the batteries in the EVs in terms of they don't like cold temperatures. So with the new W series batteries, fully IP65, and they will charge to as low as -10 and discharge to as low as -20. So, if you've got your batteries installed outdoors, you're not having to worry that once you get to those winter months, the batteries are going to shut down. With the new W series batteries, they will work at the really low temperatures. Again, full LiFePO4 on the W series with a 90% depth of discharge. And then on the W series batteries, we can have up to 32 of these connected in parallel. So it gives you, again, an idea of the scalability. Also on the W series batteries, we have a built-in 125 amp MCB built into the battery. So that will save, obviously extra installation work in adding extra isolation. And with the W series, they're available in 5.32 kilowatt hour and 10.64 kilowatt hour modules. Okay, so our high voltage batteries. So again, with our HV inverters, so the 20, the 25, the 30, and the 50, they are paired with our high voltage batteries. So on the images on the left here, you can see we've got, there's the 2 stacks. Each stack is 61.4 kilowatt hours. And that consists of 12 5.12 kilowatt hour battery modules. And again, on the 30 and the 50, we can have 2 of these racks connected into each 30 or 50 kilowatt hybrid with 10, 30 or 50 kilowatt hybrids connected in parallel. So yeah, massive, massive systems. Again, these are LiFePO4, so really safe battery chemistry. And these are really scalable. So on the slide, this one, this shows you different configurations. So the minimum amount of the individual 5.12 batteries connected to each HV inverter is 4. So the end user could start with, let's say, 4 batteries in a stack to see how they get on, monitor the data. And if they wanted to, they can add more individual modules. This is something that Segen are going to be doing directly, or they can purchase it at the full 12 modules, which is 61.4 kilowatt hours of storage. And if it's the 30 or 50, they could install 1 rack, and then 6 months down the line, they can look at the figures, the export figures, and then say, okay, yeah, we want to install more, and they can purchase another rack and add it onto it directly. Okay, so the startup procedure. So this applies. So this is showing the 50, but this applies to all of our hybrid inverters. Our recommendation as a manufacturer is when you've got a hybrid system installed and you've got your PV connected, you've got your grid connected, and you've got your batteries connected, we always recommend isolate the PV, isolate the grid, just get the system working with the batteries. So allow power to pass from the batteries to the inverter. Obviously the inverter, the screen will illuminate, and then after a couple of minutes you'll hear the relay click, and then the normal light on the top of the inverter will illuminate. And that's allowing you as an installer to check that the batteries are connected properly, and also that you've got good BMS comms. So as they're all lithium iron phosphate batteries, we've obviously got the positive and the negative connected to the inverter, but we've also got the BMS communications lead connected to the inverter into the PCS port. So yeah, with everything else isolated, that will allow you to make sure your batteries are connected correctly. And you can, on the inverter, we have in the settings, we have a screen, it says Ally BMS, and you can press on that, and that will show you all the values of the connected batteries. So the temperatures, the voltages, max charge and discharge current. So that, in that way, we've got really good comms with the batteries, and you can then introduce the DC and then introduce the AC. So you're good to go. So shutdown procedure is essentially the reverse. So isolate the AC, isolate the PV, and then you can isolate the batteries. Okay, so this is showing a 50 kilowatt. So the image we can see at the top is a view from underneath the 50 kilowatt. You can see we've got our 8 strings there with the 2 HV battery inputs. So again, each 50 kilowatt, you can have over 120 kilowatt hours of storage connected. Yeah. Okay, so on the high voltage batteries, we have a separate BMS control unit, which sits at the top of the rack. There's a full touch LCD display on the HV BMS unit. And what that will do is it will let you look at the total voltage of the rack. We can dial into individual battery voltages. It will tell us the health of the batteries, so the SOH, the state of health, the current SOC. And it will also tell you what the throughput has been, how much power has been charged and how much has been discharged. Okay, so here we can see this is just giving a quick explanation of the alarm codes. So if we've got an overvoltage or an undervoltage alarm. Okay, so in all of the boxes for our hybrid inverters, the CT coils are included as standard. So if it's a single phase unit, you'll have 1 CT, and obviously if it's a 3-phase unit, you'll have 3 CT coils in the box as standard. The length of the cable that they come with, it's about 6 meters. There is a lot of occasions where the main incomer is further than 6 meters. So what we recommend, if on some of the single phase units, if you need to extend the CT, you're good to extend it with a twisted pair up to maybe 15 meters, let's say. But if it's a longer run, or if it's on one of the 3-phase high voltage systems, we would always recommend using a digital e-strom meter. So that's connected back to the inverter on a full patch lead, and we're not having to join the CT, we're not having to extend the cables, and this is going to prevent any losses in the comms from the CT back to the inverter. So Segen do have our single phase and 3-phase E-strom meters available. Okay, this shows you the 50 kilowatt with the covers off. So you can see we've got 3 different connections there. So the top right one, we've got the generator. So that's the generator input. So our generator input port, that will do one of 3 things, but it can only do one of these 3 things at once. So it's either your generator input, we can program it as that diverter output. So that's the one that works similar to your eddy and your iBoost, or we can have it as a physical AC coupled input. So earlier we were speaking about AC coupled systems. There's 2 ways of AC coupling with our kit. We can have the, if it is an existing grid side system, you can essentially chop the AC from the grid side inverter and connect it straight into us. Or you can leave that grid side connected back to the board, and with our CTs will see when that's exporting, and it will then divert it to the batteries. Okay, so underneath the gen connections, we've got your grid connections, and then on the left-hand side, we've got the UPS. So the UPS, this is that dedicated output that's going to remain powered if there is a grid outage. And then at the bottom, you can see we've got the common earth. Okay, so on the left-hand side, we've got our terminal strip. So this is for your CT coils. So if you are using the CT coils that are in the box as standard, you would use this, the terminal strip to connect them to. So you'd have, you'd have two cables essentially if it's single phase, and then with the 3-phase, it'll be 6. But if you are using the digital E-strom meter, you'll see just to the right of the image on the left, you've got the meter input. So that will be the connection from the E-strom meter connected into us on that patch lead. So we wouldn't use the terminal strips on the left. And then the image on the right-hand side. So at the moment, the yellow cable that's in there, that's a parallel lead. So if you've got multiple inverters connected in parallel, they've each got their own grid inputs. And the only thing on our side, essentially, that parallels them is the communication lead. So the image on the right, you can see we've got the parallel lead that will then go into the inverter next to it, into the parallel input. We've also got our CAN communications, so that's back to the battery. And again, on the left-hand side of the yellow cable, you can see there, that's for our meter if you are using the digital E-strom meter. Okay, Sunsynk Connect. So this is our monitoring platform. It works really well. For installers, every system that you install, you will have full visibility of every plant that you've installed. That'll give you a full dashboard, whether it's on your app or on our Sunsynk Connect web platform. And that allows you to go into, every system. If one of your end users calls you to change some of the parameters, or they want to charge the batteries off peak, you can go into every system remotely and fully change any of the settings on there for the end user. And this is something we introduced over 12 months ago. So on Sunsynk Connect, this is more for end users. So we've introduced essentially a bit of a firewall in between the end user and the installer. So on our app, we, in the application center, end users have access to a 24-hour, 7-day-a-week live chat support facility. And this is with real people. It's not AI, it's not bots, it's real people. And what, essentially this means is that the end user can go onto the chat whenever it is, and speak to our team and ask them, okay, what does this graph mean? I want to charge my batteries. I've just moved over to a new tariff. I want to charge my batteries off peak. Can you set it up for me? And they can fully integrate that for them. So, installers love this, and users love it. And it's great having access to that, this facility. So, you've not got end users contacting you all the time to make basic settings. We can now do that for them. So yeah, Sunsynk Connect. So this is just showing you a live view of the system. So, you've got your full power flow. We've got all the graphs. So we can dial into everything. We can export data. It will give us all the green credentials, CO2 reductions, and, the equivalent trees planted. When, as an installer, when you create the plant for the end user, you then share the plant to the end user. So the end user would create their own Sunsynk Connect account. They don't need to do anything else other than create the account. And once they've done that, you will then share the plant with them. And when you share the plant, at that point, it will ask you how much, the permissions that you want to give the end user, essentially. So do you want to set them up as an end user where it'll let them have full monitoring of the system, or you can set them up as a manager of the plant, which will give them the ability to remotely change any of the settings within the app. We say that's down to you as an installer. Some end users, when they go in and change settings, things can go wrong. And especially now we've got this, the 24/7 live chat facility. My recommendation is, give the user the standard monitoring and point them in the direction of the chat support if they do need to change any settings, and our team can do that for them. Okay, so as installers on our website, we have 3 different categories of installers. We have a registered installer, so that's someone that's installed 3 or more systems, an approved installer, so 10 or more systems, and a master installer, so someone that's installed more than 50 systems. So, installers will get a lot of work from this through our website. So if you're already installing Sunsynk equipment, I urge you to go onto our website and register as an installer, and it'll ask you for a screenshot of your Sunsynk Connect account showing how many plants you've got, and we can get you uploaded on there. And like I say, you will get inquiries through our website. And for installers, we have lots and lots of training videos online. We have a massive YouTube channel, but we also have Freshdesk. So if you Google Sunsynk Freshdesk, when you go onto Freshdesk, we have a full knowledge base section on there. And then the knowledge base, if tech support are getting a lot of inquiries on one specific topic, what the tech support team will do is they will create a knowledge-based document on that, just to guide installers. So, whether it's I've purchased an e-strom meter, I need help figuring out the pinout configuration, let's say, all those guides are on Freshdesk. So yeah, if you Google Sunsynk Freshdesk, you can go on there, you'll see the knowledge base, and that will list all the documents, all the guides, just to support you. But as I mentioned at the beginning, we have that dedicated UK tech support team. And I always say to new installers, if it's your first install, reach out to us when you're on site, when you've got the system installed, you've got your comms connected to it so we can remotely access it. Reach out to our support team, say to them, look, it's my first install, please can you log into it, just check I've set everything correctly, make sure we've got the correct BMS comms, make sure the correct system modes selected, and they will go in and they'll support you in doing that. Yeah, I feel like I whittled through that very quickly, but I'm conscious that everyone is very busy. And again, thanks for joining. Let's have a quick look at the Q&A. Okay, so we've got a question here. What is the max capacity of the UPS in any inverter? So the max output on the UPS port is the rated value of the inverter. So if you've got a 5 kilowatt inverter, the max output is 5. Likewise, if you've got a 12 kilowatt single phase inverter, the max output is going to be 12. If the consumer changes utility provider, the tariff change setting can be done by the consumer, or it need installer intervention. So yeah, if someone's on a tariff and they move providers, If the off-peak window with the new provider is different to the previous provider, they can speak to their installer to remotely access it and change it. Better still, the end user can go in and speak to our 24/7 chat support team who can log into the system remotely and they can change that for them. Or, if the user is confident, they can do it themselves, either on the app if they've got access or on the physical screen on the inverter. For the 50 kilowatt hybrid inverter, how many MPPTs? So on the 50 kilowatt, we've got 4 MPPTs with 2 strings into each. So we've got a total of 8 strings over 4 MPPTs. Okay, so ventilation. So we do have, all the user manuals, which are all available on our website and also through Segen. We do have a recommended ventilation clearance. It's normally about 500 mil, but yeah, depending on the inverter. But feel free to go on our website. You can, we have a full document section, and you can download all the relevant manuals, and that will give you everything you need to know. Okay, are the HV batteries and racks available in black or cream? So to start with, it's black. So they'll all be available in black, but moving forward, we will have them available in white also. Battery voltage not mentioned. So our standard low voltage batteries are all 48 volt batteries. And then on the high voltage batteries, this is where it gets a little bit complicated. So each individual module is a low voltage module. It's a 48 volt, 5.12 kilowatt hour module. But when they're connected together, they're all connected together in series. So we're increasing the voltage at each stage. So if the minimum amount of batteries per high voltage inverter is 4. So we've got 4 times 48. So, just under 200 volts. But if someone's got the full 12 in the full completed stack, we're at, just under 600 volts per stack. Sorry, John, not sure if this has been covered. Is there any specific training for the 50 kilowatt HV unit? Yeah, so we're building a new training centre at the moment at Sunsynk UK HQ in Widnes near Liverpool. So we can communicate back through the guys at Segen, when that's ready, and then we'll get some invitations sent over. Can you put more modules, the inverter rating, e.g. 7.5 kilowatt on a 5 kilowatt inverter? So yeah, so we give the oversizing sizes. For example, on the 5 kilowatt, we say you can connect up to 6.5 kilowatt of PV. You can connect more than that. The most important thing is to make sure that your string voltages are within the parameters. So on our data sheets, you will see we've got the MPPT range. Try and stick to that, because you'll also have an upper limit on the data sheet of the DC string voltage. So let's say the upper limit is 500 volts. What we don't want you to do is size the system so you're at 500 volts, because you've got those cold, sunny mornings where you're going to have voltage spikes. It's going to take it above 500 volts, which is then it's going to put the system into alarm. So yeah, you can have more. So if, for example, on the 5 kilowatt inverter, let's say you keep your string voltage to 440 volts per string. That's approximately 11 panels per string. So it gives you an idea. You can oversize it. But, if I would only do that if they're on different orientations, because if it's all on the same orientation, there's going to be quite a lot of clipping. I've been told the Sunsynk inverters can charge the DC connected batteries from the grid side and gen terminals at the same time. Is this correct? So obviously grid side, no issues whatsoever. And then the gen terminal. So if someone's got a backup generator connected, that backup generator would only kick in if there is no grid connected. But if there is a grid outage, the backup generator would charge through the gen terminal. Apologies if I've not understood that question correctly. All right, so there's a follow-up there. If you're using it as AC couple, yeah, that's right. So if we've got the grid connection, we can charge the batteries from the grid side. Also on the gen input, as I mentioned, we can have that as our AC coupled input. So if someone's got that existing string inverter and they want to connect it straight into us through the gen port, we can charge the batteries from that gen port because we're using it as the AC coupled input, and we can also charge from the gen terminals at the same time. That's correct. Where we can find the parallel connection box for low voltage inverters for more than two batteries connected in parallel. So as a manufacturer, we say, if you're using more than 3 batteries, connected to one inverter or multiple inverters connected in parallel, we always recommend using a common DC bus bar, because on all of our low voltage batteries, the parallel leads that we supply with them as standard, they're only 25 mil square. So, as we've covered in the presentation, on some of our batteries, we can have up to 32 connected in parallel. And obviously, if you've got 32 batteries connected in parallel on 25 mil square, we're going to have quite a big problem. So if you are using multiple batteries into whether it's one inverter or a multiple of paralleled inverters, always use a common DC bus bar. We do now stock these. We've had the first shipment in. So the guys at Segen can liaise with us on, pricing and availability. So if you've got, let's say you've got one single phase inverter and 10 batteries, you would have obviously your bank of 10 batteries, and each battery you'd use the long cable set, so that the battery to inverter cable set, and that cabling would go from each battery to the bus bar on 25 mil square, and then from the bus bar to the inverter you might use 35 mil square or 50 mil square depending on how many batteries are connected. Is the 8 kilowatt 3-phase under G98? Obviously we've got the limitations of 16 amp per phase, so that should be fine on the 8 kilowatt 3-phase. But if there is any questions after this, guys, feel free to to speak to the guys at Segen, and they can loop back to me, and we're always available. Or reach out to our tech support team. You can contact them if there's any questions on an install. But, as I said earlier, if it's your first install and you're there and you're thinking, is this right? Have I done that right? Please utilize the guys in tech support. Pick up the phone, ring them. Don't be afraid to say to them, it's my first install. They can remotely access the system. They can check everything. They can make sure everything's communicating quicker. It's going to be a lot easier doing it that way than you going home and the end user saying, my batteries aren't discharging, they're sat at 100%. Let's try and get it right first time. And we've got, like I say, we've got that team there to support. Are they G100? Yeah. So all of our inverters are fully G100 V2 compliant. So you can go onto the E&A Connect database and everything is listed on there. But fully compliant. Thank you, everyone. Thanks for your time. I know everyone's busy. If there is any other questions, feel free to go on our website. In the document section, all our data sheets are on there. It lists everything. All the manuals are on there. But thank you, everyone, for joining. Thank you for using Sunsynk, and have a great day.